Okay, so now we have all the basic tools we need to be able to solve an initial value problem using Laplace transform. And so just a reminder of what an initial value problem is. It's going to be something where you have an ODE on top, just there's an example of one, and then on bottom you have some conditions. So y of 0 equals 1, y prime of 0 equals 2, like that. We're thinking about solving this type of problem. And before now, what you would do is you would solve this differential equation on top for a general solution that had a couple of unknown constants. And then at the end of doing all that, you would plug in these conditions right here to solve for what those unknown constants are. And then you would say you found the solution. When we use Laplace transforms, the initial conditions come into the problem earlier. That's just why I'm bringing your attention to that right now. So first of all, what you're going to do is just take the Laplace transform of both sides of your ODE. And that's this thing up top right there. And a couple things to note. You're going to have L of little y equal to some capital Y of S. And remember linearity. And then another thing that's going to be important is when you're taking the Laplace transform of both sides, that's when your derivatives show up. So you're going to need to use your formula. L of the nth derivative of y is s to the n times big Y minus s to the n minus 1 little y of 0 down until your last initial condition. And when you do that, you're going to plug in initial conditions. Those are these things right here. So your formula for taking a Laplace transform of derivatives of y, so for example, when you're over here trying to take L of y double prime, you're going to need these numbers from your initial value problem. And so sort of in one of the first couple steps of solving your initial value problem, you'll use those conditions, and you're used to using them at the end. So just remember they show up right here, and you need to make sure to plug them in, or else your algebra is going to be really hard later on. Because your next step is to set both sides equal to each other. There should be no y or t left. Oh, sorry. That would have been like t squared plus 1 to just use consistent notation for this section. So once you've taken the Laplace transform of both sides, all of your little y should be capital Y's or initial conditions, and all of your t's would turn into s's. And then once you've done that, this gives an algebraic equation with no derivatives. And that'll maybe be more clear when we start doing examples. But once you have that algebraic equation, just solve it. For capital Y of S equal to some stuff. And that's going to be different for each problem what that stuff is. But you're just isolating Y on one side, seeing everything else left on the other. And then your last step is to take the inverse Laplace transform of both sides. So that's going to look like L inverse of capital Y is equal to L inverse of that stuff that I said will vary by problem. And when you do that, you're just going to arrive at your solution, Y of t. Equal to something. And note there would be, remember that you can use linearity again. And also, I guess that there should be no s's left. And those are the steps. They're 4 pretty simple steps, but the actual process can be quite long. So I'm going to go ahead and stop here because the example, I think, will be more than 5 minutes, and we're going to actually apply these steps to our example in the next